In your homework for this module, you have a question that says something like, find the z-score for each score in this population. So here we have a population of 5 scores, and our goal for the homework is to transform each of these 5 into a z-score for that representing its location in this population. Now, in order to keep us on track and kind of guide our thinking, I have copied and pasted the formulas that we're going to need from the module, from the formula sheet into this Excel spreadsheet. So the first one is the computational sum of squares, which is then used in computing the variance right here. And this variance is used in computing the standard deviation right there. And of course, that standard deviation is needed inside this z formula. Also needed in this z formula are the original x scores right here and the mean of the scores. So the first thing I'm going to do is just compute the mean. The reason I'm doing that is just so that we have it and it's there for when we need it in computing the z-scores. So the mean of this set of 5 scores is 3.8. Now in order to compute the sum of squares, we have to figure out what is the sum of x squared minus the sum of x squared over n. And as you remember from last module, the sum of x squared is to take the sum of all the x's, add them up, and then square that value. Whereas this here is to square each x score first and then sum those up. So we're going to do both of those things, and then of course we have 5 scores in our population here, so the big N right there is going to be 5. Alright, so in order to get the sum of x squared, what we need to do first is to write equals this times itself. That is squaring that x value. And if I carry this down for the other 5 values, it's squaring each of these. So 4 squared is 16, 6 squared is 36, etc. Now, in order to sum them, I just come down here and I write equals the sum of all of those. Now, just to remind myself what this is, I'm going to come up here and I'm going to go under the Review tab and write a new note. Right here it says Notes, New Note. I'm just going to write a note here to remind myself that this is the sum of x squared. Alright. Then, in order to figure out the sum of x squared, I have to come down here and I have to sum up all the x values. So that's all those x values summed. I can write here, this is the sum of x. And then if I want to square that value, I just take the 19 I just computed and square it. So this right here is equals 19 times itself. And I can write this is the sum of x squared. But in order to remind me, I need to put little parentheses around this so that I remember this is the sum of x first, then squared. Okay. I can then figure out the sum of squares by taking the sum of x squared, which I just computed here, and dividing it by big N. So I take this, 361, divided by 5. And that right there is the second component of the SS. And if I take the sum of x squared, which I just computed up here as 81, and I subtract from it the 72.2, I can write down here that this is the sum of squares. It equals the sum of x squared minus the second component of the equation right there, and you get 8.8 as the sum of squares. That 8.8 can be used in this formula. So if I want to figure out what is the variance of this population, I just take the sum of squares divided by the big N, which is 5, and there you have the variance. In order to compute the standard deviation, I take the variance and square root it. So this is the standard deviation. I take the square root of 1.76, and the standard deviation is 1.32. That's going to come in handy in our z-score formula. So over here, I'm going to write z-scores up at the top. I'll underline that so that we remember that that this is the column header. And underneath that, I'm going to create a new formula for each of these values in the original population, transforming them into z-scores. So what I need to do is take the original x, which is here, minus the mean from it, which is here, and then divide it by the standard deviation, which is here. So I just come here and I write equals the original x minus the mean. But of course I want to use the same cell for the mean every time, so I push F4, and that includes dollar signs around the B and the 9, and that will indicate for the computer that I never want to use anything except for B9 as the mean. I can put parentheses around this so that it tells the computer, do the numerator first, do x minus the mean first, and then after you're done with that, then divide by the standard deviation. And the standard deviation, of course, we've computed right here, so we divide it by that cell. We always want the computer to use that same cell, so we push F4. That locks in the B15 into place, or you can just add those dollar signs manually. And once you've done that, then you can push Enter, and you've computed your z-score for the first x. If you carry this through, then you have computed a z-score for each of the individual original x scores. So the z-score for 2 is negative 1.35. The z-score for 4 is 0.150. The z-score for 6 is 1.6. Well, I guess you're supposed to be rounding these, 1.66. And you can see that we've just very quickly and easily computed the z-score for each of these in the population. Now, I expect you, when you're finishing your module homework, to copy down what you've done in Excel, because if you don't show your work, there's no way for us to know how you've got what you've got. But this, using Excel, will make your homework a lot faster and easier than having to type out each of these formulas in your calculator one by one.